Okay, let's give you guys some more practice. So similar to the previous video, establish if this sequence will be monotonically increasing or if it's monotonically decreasing. So we don't really care about, I'm not asking for the upper bound or the lower bound. Forget about the bounds. Just establish if it's going to be monotonically increasing or if it's monotonically decreasing. Remember, there are two ways of doing it. One way and the other way is to turn it into a function and then look at the first derivative and so on. So establish if this is going to be monotonically increasing or decreasing. So press pause and have a go. Okay, so let's look at the first method. I will then later show you the second method. So let's just look at this method. So the first method, remember this is our sequence generator. If this is an, then an plus 1 would be, well, if you look at this here, this is n here. So our next term, an plus 1 would be n plus 1 here and then plus 1 here. That's why you've got your n plus 1 and then n plus 1. Well, anyway, n plus 1 will be this, an will be this. So this method here is to get the next term divided by our current term. So well, put this into here and then put this into here. That will then give us this thing. Well, don't forget, and then you times the reciprocal of this thing here. Yeah, so we'll then give you this. So now it's top times top, bottom times bottom. That will then give you this. That will then give you this, and then you can see that this is exactly the same as this, but then you've got this thing, this extra tiny bit here. So that will mean that this thing here, because you've got exactly the same, and then this exactly the same, but then an extra bit. That must mean that the whole thing here must be less than 1. Well, if this thing here is less than 1, then we could definitely say that it's monotonically decreasing. Okay, so after all that, it is monotonically decreasing. And the second method is to turn our sequence into a function. So that will then give us the second method is to turn this into a function and then look at the derivative of the function. So when you differentiate this, it will then give you this. It's really you using the quotient rule. So use the quotient rule, and then that will then give you this thing here. So f prime is given by this. Now if you look at the remember n is always from 1 to infinity. So we don't really care about n being negative. Well, if you look at this thing here, this whole thing here will be negative. So the first derivative being always negative, it will mean that the function itself must be falling. It must be decreasing because the first derivative is always negative. If the first derivative is always negative, that must mean the function itself must always be falling. So it is monotonically decreasing because the first derivative is negative. And then if you look at the second derivative, it gives you some information about the bound, even though the question even though I said that we don't care about the lower or the upper bound. But then if you look at this the second derivative, it gives you some information about the bound. So this is our first derivative. Rewrite this as this. So now differentiate it because we want to find the second derivative. We want to find the second derivative. So differentiate it. It will then give you this. Now the second derivative, remember n is from 1 all the way to infinity. We don't care about n being negative. So this thing here is going to be positive, and then this whole thing here is always going to be positive. So the second derivative being positive, it will mean that it must concave up. So it must concave up, meaning that there must be a lower bound. So by looking at the second derivative, it gives us some information about our sequence. There must exist a lower bound because it's concaving up. It's concaving up. So if you get a graph plot and plot this. So in the previous video, we looked at this. In this video, we were looking at n plus 1 over n. Look at this. It wants to concave up. It wants to concave up. this is it wanting to concave up. But the thing is, at the same time, the function is always decreasing, and you can see that it's always decreasing. It's always going downhill. It's always going downhill, and at the same time, it is actually concaving. It wants to concave up. It is actually concaving up. It's kind of strange that it's concaving up, but yet it's always decreasing. Okay.